Lesson 1. Vector quantities. Definition: a quantity that is both magnitude and direction. Displacement: how far an object is from its starting point. Overall change in position. Velocity: the rate at which an object changes position. It does not matter whether the object is speeding up or slowing down. If an object is moving rightwards, then its velocity is described as being rightwards. Acceleration: defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. Lesson 2. Scalar quantities. Definition: quantities that are fully described by a magnitude or numerical value alone. Distance: how much ground an object has covered during its motion. Speed: how fast an object is moving. Speed can be thought of as the rate at which an object covers distance. Instantaneous speed: the speed at any given instant time. Average speed: the average of all instantaneous speeds, found simply by a distance/time ratio. Lesson 3. Acceleration. Definition: a change in velocity/change in time. Units. These are all the units for acceleration. Definition: whether the object is speeding up or slowing down, whether the object is in positive or negative direction. When an object is slowing down, the acceleration is in the opposite direction as the velocity. Thus, this object also has a positive acceleration. When an object is speeding up, the acceleration is in the same direction as the velocity. Thus, this object also has a negative acceleration.
Okay, our next lesson is position versus time graphs. Now, this is part 1, and we're going to look at some other graphs in part 2. So, a position versus time graph tells you the velocity of an object at any given moment. This is correlating to the velocity equation, which is change in position over change in time, which can be seen in a graph. Now, first type of graph, this one right here, is constant velocity of a positive velocity. It'd be going, if it was on the other side of the line, it'd be negative velocity. But regardless, this is a constant velocity. Now, the one next to it, to the right, is also positive velocity, but its velocity is changing. It's not constant. And because it's changing, the slope of the line is curved. Now, the last graph is also positive or rightward, but it is slow moving because you can tell by the steepness of the line. But regardless, that if the line is straight, it's a constant velocity, and if the line is curved, it's a changing velocity, and you know this based on the slope, because the slope of the line can tell you information about the velocity of an object. Now, for part 2, we're going to look at other graphs. Now, for a negative velocity, for a negative change in velocity, your line is going to be curved because it's changing. Now, if it's slow to fast, it will be a hill type curve. But if it's fast to slow, it'll be an incline. Now, there's a difference. Slow to fast is negative, but fast to slow is leftward. Because one is stopping and one's going in terms of speed and acceleration. But that's something we don't have to worry about because this is a velocity graph. Now, the next graph we're looking at is the fast rightward. Now, a fast rightward constant velocity is having a straight line going up. But a fast leftward will have constant velocity going down. But a slow leftward constant velocity will be going down steeper. Then all of this is based on the slope of the line. Let's say we have a positive velocity from slow to fast. It'll be the inverse of this graph. Just as a rightward fast to slow would be the inverse of this graph. It'll just be going in a positive or rightward direction, but the curve will stay the same. Now, lesson 4, part 2, is velocity versus time graph. Now, these are different from position versus time graph in the instant that it's velocity over time instead of position, which gives you the acceleration of an object at any given time instead of velocity. Okay, so the first graph we're going to look at is this one. This graph is flat all the way across. This is a constant acceleration. It's constant velocity, it's constant acceleration, meaning that there is no acceleration. This is a constant velocity graph, which shows that there's no acceleration. Acceleration is 0. And the next graph we're going to look at is these two right here. Now, if it's a straight line up or down, then the acceleration is increasing. But if it's inclining, as you can see here, like if it's going towards 0, it's slowing down. If it's going away from 0, it's speeding up. 0 is that point of no speed on a velocity versus time graph. So it's easy to tell when it's accelerating or when it's decelerating, which is not technically a word because it's all acceleration. But it's easier to see when the object is speeding up or slowing down. Next, we're going to draw our attention to this graph right here at the bottom. Now, when an object is moving with a positive velocity, it is going to be on the positive axis. So it will not be on the negative portion of the graph. As you can see here, neither line is in the negative part of the graph. But if it's a negative velocity, it'll be under 0. It'll have a negative y-axis. So anything with a slope of a negative x will have a negative leftward velocity. But if a graph were to be speeding up and going in a negative and have a negative velocity, it'd be under 0, heading further away from 0.